In this next video, we're going to find an explicit solution of the differential equation that satisfies a given initial condition. So all that to say, we're going to consider this differential equation. We're going to use the separable equations technique. We're going to use an initial condition to find the integration constant, and from it, find an explicit solution, or a solution that's of the form y equals a function of x. So let's go ahead and proceed with this problem. So the problem that we're given is dy dx is equal to x sine x all over y. And for these types of differential equations, we can separate each variable of each type to the left and the right. On the right-hand side, we're going to try and do all the x's. On the left-hand side, we're going to use all of the y's. And that's basically dictated by the left-hand side in the numerator. We have a dy, so we're going to keep that over there. Whereas downstairs, we have a dx, so we can multiply both sides by dx to get a dx on the right-hand side. So let's go ahead and do that. So we have dy on the left-hand side. On the right-hand side, we have x sine x all over y dx. And now we still have some y dependence over on the left-hand side in that denominator. So we can multiply both sides by y to get all of the y's finally on the left-hand side. All right, so now that we have all the y variables on the left-hand side, all the x's on the right, we can go ahead and integrate both sides. And at this stage, we start asking ourselves, okay, what do those integrals look like? What techniques could we use to integrate them? And well, if we look at this on the left-hand side, the integral of y with respect to y, we're going to be able to use an antiderivative power rule to give us that, compute that integral. Now on the right-hand side, though, we have the product of x times sine of x, where we're thinking, how can we compute this integral? We're going through our list of integration techniques, u sub, integration by parts, trig sub, all of those things. And well, the one that makes sense here is going to be an integration by parts. Since we have the product of two functions, and neither function looks like a derivative of the other, so u sub is out. So let's go ahead and try integration by parts. So remember, for integration by parts, we choose something to differentiate. That can be our u. In this case, we're going to use x is u. Then we find the derivative. Du dx, in this case, is 1. So du is just identically equal to dx. And then for integration by parts, everything we didn't call u becomes our dv. So in this case, dv is sine of x. So v is equal to minus cosine of x after we have integrated the dv portion. So let's recombine what we have so far. And that integral on the left-hand side, I'm just going to keep this as the integral of dy for right now. If you want, feel free to go ahead and integrate that. I'm just going to leave that for the time being, since we know we can go ahead and use the antiderivative power rule for that. Now let's recombine what we have on the right-hand side. So remember, for integration by parts, we have u times v minus the integral of v du. So we're going to fill in all of those characters in a moment. So let's just go ahead and do that. So our u in this problem was x. The v that we found was minus cosine of x. So again, that's our u and v. Well, I messed up my color convention. And then we subtract from it the integral of v, which is minus cosine of x, times du, which in this case is just equal to dx. So I'll just point these things out. This was our u, this was our v, this was our v, and this is our du. And again, what we're hoping to see through this integration by parts is that we're arriving at a new integral that's easier for us to do. So let's just clean up what we have so far. So left-hand side, again, I'm just going to carry this integral around. The right-hand side, this is a minus x cosine of x. And then we have a plus sign here. We also have we have a minus sign in front of the integral, a minus sign in the integral. So altogether, that becomes a plus the integral of cosine of x. And this integral of cosine of x is an integral that we can go ahead and do from our list of antiderivatives. So at this moment, we can do that integral on the far right, the integral of cosine, and we can also just do the integral of y with respect to y. So let's do both of those next. So the integral of just y with respect to y gives us a 1/2 y squared. On the right-hand side, we have minus x cosine of x. That's just the product of those two functions. And then the indefinite integral of cosine is plus sine of x. And then finally, we need an integration constant somewhere, so we'll just put a plus c over here. And at this stage, again, we have an implicit solution. Now, we haven't used the initial condition yet, so we still don't know what c is equal to. And we're told in this problem, we also want to find an explicit solution in addition to figuring out what that c is, given the initial condition down below. So let's go ahead and just use the initial condition right now. So the initial condition that we're given is that y of 0 is equal to -1. So again, what this reads as is when x equals 0, we're told that y is equal to -1. So the reason I'm pointing this out is because we can substitute that information into our implicit solution, that we found up above. And once we substitute those x's and y values, we'll just get some number, we'll get an equation that's the only unknown will be c that we can solve for. So let's substitute that into the equation above. So anywhere there's a y, I will substitute a -1. So we have 1/2 -1 squared equals, and anywhere there's an x, we can substitute in a 0. This left-hand side, we have 1/2 times -1 squared. That whole thing turns into a just positive 1/2. On the right-hand side, well, we have 0 times a cosine of 0. So 0, of course, is 0. Cosine of 0, well, we can write that as 1 just for some practice. But that all together just gives us a 0. Sine of 0 is also 0. So the right-hand side just gives us a c. So at this junction, we know what the integration constant's equal to. In this problem, it's equal to 1/2. So we can substitute that back into our implicit solution up above, just replacing that c with the 1/2. So I'll just say substitute what we have for c. So we have 1/2 y squared equals -x cosine of x plus sine of x. And instead of c, we can write a plus 1/2. Now this solution is all fine. It's an implicit solution because we have some relationship between y and x, as in a function of y on the left-hand side equals a function of x on the right-hand side. So again, function of y on the left, function of x on the right. But what we're looking for in this problem is an explicit solution where we're looking for y equals some function of x alone. So we get to do a little bit of algebra here. So multiply both sides by 2 to try and get y by itself. So we have 2 times the quantity minus x cosine of x plus sine of x plus 1/2. So we have to be careful with parentheses and brackets and everything here. So again, that's a minus sign in front because that 2 is going to multiply everything on that right-hand side right now. Next, we can take the square root of both sides to just get a y by itself on the left. So we get y by itself on the left after we do a square root on both sides. So we have underneath the square root a 2 times minus x cosine of x plus sine of x plus 1/2. All of that is still underneath the square root. But there's an important thing that we need to do. We also need to include a plus or minus here in front of the square root, because if we square both sides right now, we want to get back to the previous line. But because we took the square root from y squared to y, this could either be the plus square root or the minus square root, because when we square it, it's just going to get rid of that plus or minus altogether. And the reason why I want to go through this problem in particular is we're told at the beginning of this problem that we had this initial condition that when x equals 0, y equals minus 1. So if we're looking at what we have down below, let's try and substitute in what happens when x equals 0. So remember, from initial condition, and the reason we're doing that is it'll help us determine whether we need the plus sign or the minus sign in front of that square root. So from the initial condition, we have x equals 0, or I should say when x equals 0, y equals minus 1. Okay. So if we just plug in x equals 0, we can see what's going to happen. So we have 2 times, again, plugging in x equals 0, we'll have minus 0 times cosine of 0 plus sine of 0 plus 1/2. And just like we saw before, well, 0 times cosine of 0 is 0, sine of 0 is 0. So underneath that square root, what we have so far is y is equal to, well, plus or minus that square root of 2 times 1/2, which it looks like y is equal to plus or minus the square root of 1, which is just plus or minus the square root of 1. And again, what we care about in this solution from our original initial condition is that when x equals 0, y is equal to minus 1. So at this stage, what we need that y to equal down below is we need this to be y equals minus 1. So when we're looking at our final solution here, since we need that to be y is minus 1, we only need the minus sign from in front of that square root. So if we go back up to our solution for the explicit solution, we need that to be y is equal to minus the square root of all of that stuff. 2 times the quantity x cosine of x minus x cosine of x plus sine of x plus 1/2. And that would be our final solution in this case. So the thing to watch out for in this particular problem is when we went ahead and solved for the explicit solution, we basically got this plus or minus in front of the square root. But because we had that initial condition down below, only either the plus sign or the minus sign would have worked in front of that solution. So we just need to remind ourselves what the initial condition was so we could choose the appropriate sign in front of that square root.